Yes, guys, today's topic is very basic, real-time DevOps day-to-day. How to create cluster at AWS EKS using Terraform. This is very basic, but also some tricky if you are the new guys. So focusing the new guys or newbies in the DevOps, I have created this one, and I made it simplified because lots of YouTube videos making complicated this one. So I made it really simplified. Just how many things? One, two, three, four elements or four components I have added. So I have started like local.tf. It has the cluster name. Then EKS addons.tf. It has the storage, especially EBS CSI driver I have given. Then vpc.tf. It has the networks. Then eks.tf. It has the desired node size, min max also, so node size. So only these four component, if you can execute or apply in the Terraform perfectly, you can create easily the EKS cluster. And I am adding this one in my GitHub repo, Control C. Sometimes I forgot. So in the DevOps 0 to hero, just adding one more file. Control V. So everything is here. You can practice from here. I'm making this one changes here. So this is now here. EKS cluster created by Terraform cluster. So let's go to the real project. One server I have to launch with EC2. It's coming. Giving the name like Splunk server. Okay. Then I'm using the Ubuntu. Okay, T2 micro. No, I have to take something bigger. So I'm taking like T2 medium, 2 CPU, 4 GB byte memory. Okay. Then I'm using the default key pair and my default VPC also. Creating a firewall and for HTTP traffic from internet, port 80. Allow HTTPS also. Also I'm adding some extra GB here, like 30. So launch instance is coming. Yes, Splunk server is here. So this is the public IP. I'm using this one for our mobile extreme. Session SSH. Control V. Specify username like Ubuntu. SSH private key. Default key. Yeah, it's coming. Now I have to edit the security group here because I had to add inbound rule for Splunk. So Splunk inbound rule, especially this is 9997 custom anywhere. So we can give the name like Splunk. This looks good. Yes, we are now all set to go. So here I have to do user data. Just I'm making a one user data. Control C. Sudo apt update first. So here I am making one sudo vim install.sh, then inserting here with bin bash sudo apt update, then install unzip, then AWS CLI should be, then install Terraform, install EKSCTL, kubectl, ask colon wq. Yes. Now ls chmod plus x install.sh. It should be sudo. Okay. Now ls, see the color is changed. Earlier was white, this is now changed. Now // install.sh. Yes, now everything is going there. I have shared this one with you guys in the script GitHub. Yes, so I have to press enter. It's taking a bit time. Yes, it looks good. Control L, AWS version. Yes, and EKSCTL also see EKSCTL version. EKSCTL. Yes, then kubectl. Yes, then Terraform. You have to see everything is good or not first. Yeah, so everything now I have to do AWS configure. So access key ID, secret access key ID, I have to take from identity access management, this one. User, create user. So user for Splunk, user, attach policy directly. I'm giving the administrator access, the highest one. Then just create. So where this is Splunk user, I have to go there. I need the security credentials, right? So access key, create access key for CLI, confirmation, next, just create. In the real time I have to save this one. You have to also, but after this demo I just clean up this one. Okay, then secret access key, then default region name US East 1 I'm using. Output format JSON. So let's recheck S3 ls. My buckets are shown up, not yes. So everything looks good. So first of all I have to create locals, sudo vim locals.tf. So here I am adding the name, cluster name for the locals. So locals, then curly braces inside cluster name equal Splunk EKS cluster. You can change the cluster name also, colon wq. So then I have to add also EKS add-ons, because EKS needs add-ons. So sudo EKS add-ons.tf. Here I am adding the add-ons. I'm copying from my node, then right click. So here the add-ons actually for data, AWS IAM policy, then EBS CSI policy, then ARN, This is the ARN for policy service role, Amazon EBS CSI driver policy, then module IRSA EBS CSI, then source Terraform AWS module slash IAM, AWS modules IAM assume role, then with YDC. Version 5.24, create role equal true, role name, this is the role name, and module.eks dot cluster name, cluster underscore name, it will come from the locals. Then provider URL, this is the module.eks YDC provider. Then role policy ARN, this is coming like this way. YDC fully qualified subject, this came like this way. Resource AWS EKS add-ons, then EBS CSI cluster name, module.eks dot cluster name is coming same way. Add-on name AWS EBS CSI driver, add-on version is coming like this way. Then service account role is here. Tags EKS add-on EBS CSI Terraform true. So s colon wq. So here our created this one. Now I have to create also bpc.tf. Without bpc nothing is done. So sudo vim bpc.tf, right click. So here module, the whole module name is bpc source Terraform AWS module slash bpc slash AWS, then name Splunk infra. I have given this name, you can change this one. CIDR is very much important. So this is the parent CIDR. So bpc CIDR 10.10, so slash is 16, that means 65,000 IPs there. Edge is availability zones 1, 2, 3. US East 1, East B, 1B and 1C. Then here is the private subnets. It should be inside this one, 10.10 then 0.1. See here 10.10.2, 10.10.3. same way public subnet 10.10.101, 102, 103 and slash 24, 24, 24. That means 256 IPs there, slash 24. Okay, then enable net gateway equal true single net gateway. So first we have to enable, then how many single net gateway, true. Enable VPN gateway, false. Enable DNS hostname, true. So this is the gateway and host names. Then public subnet tags kubernetes.io is coming like this, shared. Then kubernetes.io elb is equal to 1. Then private subnet tags, so same thing is coming like this way. So bpc is coming as a whole like this way, swq. So here is how many things. Let's see first. We don't need this one. So rm aws cli dot, yeah, we don't need this one. Okay, so EKS add-ons locals.tf and bpc.tf, that means add-ons, locals and bpc, these three guys are here. Now I have to create eks.tf. So when creating the EKS, we need at least these three things. Locals has name, bpc has networking, add-ons has EBS CSI driver. So normally these three things are needed. So sudo vim eks dot tf. Okay, so here the module name is EKS source. This is the Terraform source for EKS. Version 19 I have given here. We can change also. Then cluster name local.cluster name. So from local it will come the cluster name. Then cluster version 1.31 I have taken. VPC ID module.vpc. So the VPC module we created, right? From here the VPC ID will come. subnet id same module.vpc.private subnet. So we are giving the private subnet here. Cluster endpoint public access true. Then EKS managed node group default AMI type. Then EKS managed node groups. Then one name Splunk forwarder. I've given the node group name Splunk forwarder. Instance types T3 medium I have given. Minimum 1, max 3, desired is 2. Very much important is desired. So it will create it 2. Okay, so now ask colon WQ. So now we have to do Terraform init first. Then we have to see the Terraform plan. What's going on? Terraform init is initializing. It's taking a bit time. Control L. So after any changes, this is the best practice. No, not this. See the ls. If any changes here, no, nothing changes after init, right? So let's see here, Terraform plan. So it looks good. 56 to add, 0 changes, 0 destroy. So I have to do Terraform apply, right? So Terraform apply. It will take times. Asking for yes. If I give the auto approve, then no need for yes. It's taking times at least 14 or 15 minutes like that. It's creating first VPC. See, first of all VPC. We can see our VPC. Where is VPC? VPC. Open in new tab. This one. This is the Splunk infra, our VPC name. Can you remember? So this is the thing. Always I see the resource map. In the resource map, everything is clear. How much taking? So public is created, but NAT gateway takes times. So our region is US East 1, A, 1, B, 1, C in the VPC. Can you remember? So all are here. See NAT gateway. NAT gateway is taking time. NAT gateway. It's taking times. When NAT gateway will be created, then here and the route table, this private, it here the NAT gateway will be here. It will be connected with private one. So at least 15 minutes will be done. Also let's see EKS. We can see there, new tab. Splunk EKS cluster creating. This is still version 131 I have given, right? So let's go there inside, and this is the overview is here. Created 2 minutes ago. ARN is here. Resource, all I see resource 1. Still nothing showing up like that. So let's go there. Resource, then compute. Still not. Node group will be created here. Node group we'll see here. Then networking, This is the VPC subnets, cluster security group, still not here. Add-ons, here we will see that AWS CSI driver. So it's still creating the cluster now. So net gateway is created as per this instruction. So let's do the refresh, making the whole thing refresh. Terraform is easy if you give everything perfectly. If you don't give, then the problem. See here, this is connected. So yeah, private. This is connected with net gateway. This is the net gateway here. Splunk Infra US East 1A. So net gateway always staying in the public subnet in one region, but it's connecting the private, all the private one. Okay, so this is the IGW with public route tables, and this is the private one net gateway, one route tables. Okay guys, it's still creating. We can hover some here. Add-on not, we can see which one is creating. Cluster.this, okay, inside the cluster still. So this is the cluster. This is the resources. Okay, resources, this is the port level. Compute, node is coming here, not yet. Networking, add-ons, nothing. Access, observability, not. History, tags, not yet. So resource type, ports, replica set, then deployments, stateful set, daemon set, cron job has cron job, then priority classes, horizontal, pod, autoscalars, SPA. Okay, yes guys, so it looks that this is done totally. So let's recheck here. Here is 1 2 extra EC2, that means this 2 node is created, and this is our cluster. Let's see our cluster. It's now active. So let's go there. Now lots of things. See, API resources here. Pod level is still nothing. Compute. Okay. Compute also not showing. Then networking. Add-ons. So add-ons has come here. Amazon EBS CSI driver. Okay, this is the persistent volume. It will give this volume here. IAM role is IRSA. Okay, version 139. Okay, so resources, still nothing. And node is still now visible. Node group, Splunk forwarder, desired is 2. So I am release 131, AMI release. Okay, so desired is 2, right? And name is Splunk forwarder. It has the first name. Okay guys, it looks good now. See now, kubectl get node. It's not showing in the CLI, but we already watched that we have the node group, right? Node is created already in the console, but not in the CLI. I have to do AWS EKS update kubeconfig, then the name, which name is for our EKS, or EKS name, which one, that one is important now. Let's recheck our name. So our cluster name is Splunk EKS cluster, right? This is the name. Okay, copy, then hyphen region. So region is US East 1. Okay, added new context, this one, cluster Splunk, this is to home Ubuntu kubeconfig dot kubeconfig, this is the location. Okay, so let's try our get node now. See here, now showing. Earlier it was not showing because it should be added to this location home Ubuntu kubeconfig dot kubeconfig.